This is the Chapter 23 review. For the test on Chapter 23, you need to focus first on the main ideas. Make sure you have these down. You have a separate quiz just over the main ideas. And then fill in from the supporting information the details. Start with the big ideas. Make sure you're clear on the meanings of the words. Try to keep the organization straight in your head. And remember as many of the supporting ideas as you can between now and the time you take the test. So I'm sure you know the primary functions of the respiratory system involve delivery of oxygen and removal of carbon dioxide. When you inhale, oxygen's coming in. When you exhale, you're removing the carbon dioxide. That carbon dioxide is generated inside of your cells when oxygen is being used. We divide the actions of the respiratory system into four main events: pulmonary ventilation, which is breathing; gas exchange, which is the transfer of oxygen and carbon dioxide across membranes; and external respiration, that's in the lungs; and internal respiration, that's in the systemic tissues; and finally the transport of the respiratory gases in the blood. So with pulmonary ventilation, you're moving fresh air in. Fresh air is high in oxygen, very low in carbon dioxide, and you're moving stale air out. And the part of the respiratory tract that the air is just moving in and out through is called the conduction pathway. And the conduction pathway is subdivided into the upper respiratory tract, which is in your head, and the lower respiratory tract, which is in your chest. Breathing is the most easily measured of the respiratory functions, and we measure breathing with measurements of the pulmonary volumes and capacities. Pulmonary volumes are sort of subdivisions of the lungs. Capacities are combinations of those volumes, and you can measure by how much air you inhale or exhale through a special device called a spirometer. And then from that, we can calculate the ventilation rate just by counting how many breaths you breathe in a minute. One of the first things that the respiratory tract does is it warms, filters, and humidifies the incoming air. If you've ever been outside on a cold day and breathe through your mouth, you know that the functions of the nasal cavity are really important. Air hitting your throat from your mouth in cold weather really makes your throat cold, much more so than breathing through your nose. So as air passes through that nasal cavity, most of the warming is done at that point. Filters remove particulate matter and potential pathogens from the air. Humidification is important. You have to add water vapor to the air to keep from drying out your lungs. Okay, up to number 6. Pulmonary ventilation requires respiratory centers in the brainstem to send signals. These respiratory muscles are voluntary skeletal muscles, so unlike the heart, which will beat all by itself, breathing requires repeated stimulation from the respiratory centers in the brainstem. If anything happens to the brainstem to prevent it from sending these signals, you simply stop breathing. Because air is a mix of gases, you have to have some understanding of the gas laws to understand what makes the air move in and out of the lungs, and what makes oxygen and carbon dioxide diffuse between the alveolar air and the body fluids. The place where the respiratory gases get exchanged, oxygen and carbon dioxide, is called the respiratory zone. The respiratory zone is the part of the lung where the wall dividing the air from the blood is thin enough to allow those gases to diffuse. And that, of course, is mostly at the alveoli. Gas exchange occurs between alveolar air and pulmonary capillary blood. That would be external respiration. So down to number 9, the physiology and anatomy of the alveoli and pulmonary capillaries are coordinated for efficient gas exchange. Now, I don't have anything else in this review on this, so let me say just a word about that. The deeper you breathe, the more fresh air you get into your lungs, the more you dilate the blood vessels in the pulmonary circulation. More air, more blood. Less air, less blood. So if you're sitting at rest and breathing fairly shallowly, you're sending less blood to the lungs than you do when you're exercising. That's pretty intuitively obvious, I think. Okay, number 10, respiratory gases are transported within the blood in erythrocytes and plasma. In other words, the respiratory gases are physically dissolved in the plasma, and additionally they are chemically bound within the red blood cells, the erythrocytes. Oxygen and carbon dioxide concentrations are controlled through homeostatic feedback loops. And as we get into the supporting information, we'll see what the reflex arcs are that coordinate the regulation of oxygen and carbon dioxide. Number 12, very important, carbon dioxide influences blood pH. And here's what you need to remember about that. When carbon dioxide increases, blood pH decreases. Remember that acids decrease pH, and carbon dioxide, when it gets dissolved in water, converts into the acid carbonic acid, which lowers the pH. Since brain function is sensitive to pH and carbon dioxide, it makes sense that the regulatory centers of the brain are more sensitive to pH and carbon dioxide than they are to oxygen levels. The centers in the brainstem are in the medulla and pons, and they regulate both the rate of ventilation and the depth of ventilation to maintain homeostasis of pH, carbon dioxide, and oxygen levels. And the main way they do that is that they have feedback from chemoreceptors. These chemoreceptors respond mostly to pH and carbon dioxide, and to a lesser extent, for the aorta and carotid bodies, to oxygen. The medulla is very sensitive to CO2 and pH, and that provides feedback to the brainstem centers for regulation of breathing. Okay, that's the 15 big ideas. You have a separate quiz on these, drill and practice, make sure you have those down, and you ought to do well on at least half of the test questions if you understand the first 15, the main ideas. Now as we get into the supporting information, you have the anatomy and histology of the respiratory tract. You have a separate section on pulmonary ventilation. You have a section on gas exchange, a section on transport in the blood, and a section on regulation of respiration. Make sure that you, as you go through these, that you keep straight which ideas belong in which category. That will help you remember and work out the test questions. I'm going to stop here for now, and we'll come back and do a separate section on each of the 5 areas. See you soon.